Okay, thanks for this introduction. And as you say, today I will talk about generative AI and how to use Python libraries to build and use generative AI models. But before to go to the talk, just a brief introduction about the company where I'm working right now. We are Symphony Prime Group, which is an holding of different companies that aim to develop digital transformation. And in particular, I work in Overture, that is the technological boutique that is going to deliver solution in cloud, and in particular in Google Cloud, because we are a Google Cloud partner. So going to the talk, I will give you an introduction about generative AI, so the theoretical concepts, and then I will move to generative AI models and the difference among the models that are nowadays used. And then I will talk about how to use Python to build and use these generative models. So about the introduction, generative AI is a particular branch of artificial intelligence, even if today we are going to talk almost always about only generative AI. Of course, there is a lot out of generative AI. But this part of artificial intelligence is used to generate original content. We can use generative AI for a lot of tasks, for example, in art, in music, design and fashion, literature. Okay. And since it is something that is going to grow very, very quickly, there will be a lot of application that nowadays we don't know and will come very soon. Of course, Python, as a versatile programming language, is the most used and the popular choice for building and use generative AI models. And we will see the main libraries that are used today in this particular field. So before to move to the Python part, there is a big difference between discriminative models and generative models. Discriminative models are basically the ones that we can see here in the picture on the left, which are basically the ones that are used to predict some labels. So for example, in the most simple case where we have to decide about spam and not spam email, we put a boundary decision, and this is something that is discriminative. And then we have generative, where basically we do exactly the contrary. So we aim to predict the feature and not the label, as we can see on the right. And these kind of models, as I said, can be used in several domains. And today, as we can see in the talk, we talk a lot about large language models that are used basically in all the text domains. So moving to some details about the difference among the generative AI models. First of all, I want to introduce the Python libraries that we will see in the talk, and that are the most famous used today for this kind of AI branch. So we have, of course, TensorFlow and PyTorch that are one of the most famous artificial intelligence frameworks, and these kind of frameworks also in generative AI are used, and are used in particular to build GANs, VAEs, and transformers. And then we have Hugging Face, that is this popular open source framework that is used in particular for tasks that involve transformers models. And then we have LangChain, that is something that orchestrates the solution, as we can see later, and are in particular used for large language models. So as I said before, generative AI is not just large language models, even if today, basically, we listen about large language models everywhere. There are a lot more outside, and there are the most common generative AI models that are used and built in generative AI are GANs, that are Generative Adversarial Networks and are particularly suitable for images. Then there are Variational Autoencoders that are particularly suitable for anomaly detection. And then there are transformers, so large language models that are particularly used for everything that is regarding text manipulation. Starting from variational autoencoders, these kind of models describe an observation in a probabilistic way. So basically, we are not going to have an exact result starting from the input data, but we are going to have something that in a probabilistic way is very similar to the input. So for example, here in the image, we can see that starting from the image on the left, we can have something that is very similar but is different because the generated image has glasses. And these kind of models that are used for anomaly detection, but also for image generation, are built by two different architectures, a decoder and an encoder, as we can see later. So the architecture of the model itself is very complex because it's not just a single architecture, but it's made up of two of them. In a similar way, generative adversarial networks that are made up of a generator and a discriminator. So also in this case, we have two architectures and not one. And generative adversarial networks that were introduced for the first time in 2014 are going to be very powerful for what, and are already very powerful for what concerns the generation of new original images. And then, last but not least, we have transformers that are the core of the language models, and these are basically what we hear about today. About everything is going to regard language. Transformers are very powerful because thanks to transformers, we have a new way to manipulate text and to make text generation, translation, summary of text, and also image processing, but not as a GAN can do. The most famous models that belong to this group are GPT and BERT, but also Lambda. We will see in detail later, but of course, every one of us has heard about GPT. Here, just a schematic view of the core differences between the three models that we have just seen. So basically, VAE in the first column, GANs in the second, and transformers in the third. And in the last row, we can see basically the most common use cases that can be done by using one of these architectures. So moving to the Python part, I will show you how to build simple architectures by using Python for all of these three main group of models. So starting from GANs and VAE, basically we can build a very simple GAN architecture by using TensorFlow and Keras. So as we can see on the left, we basically need to import the common layers part of the TensorFlow and Keras libraries. And then, as you can see on the left, on the right, you can have basically the building of a generator model by using the sequential method that belong to Keras. You can then build the discriminator model, and then you can compile everything to have a single architecture. Then, of course, you have to put all the part that is related to the manipulation of data and so on. But just as a schematic view, the main part that compose an architecture that is a GAN are these two, generator and discriminator. That can be more complicated, of course, and you can add layers and so on the base of the complexity of the task. And in the same way, for the variational autoencoders, we can use TensorFlow as well, and here the difference is that we use convolutional neural networks in the case of VAE, and also the other difference is that instead of having a generator and a discriminator, we have an encoder and a decoder. And in the same way, we have the first architecture that is the encoder and use convolutional 2D method. And then we have the decoder that is going to use convolution 2D transpose method because this method is used to manipulate the output. And then in the same way, you can compile your model, you can train it on several epochs, and so on. Moving to large language models, here, as I said before, large language models are used for everything that is going to concern text data. And the large language models that are on the market today are basically trained on a massive amount of data. And we use them as pre-trained model, and then we can fine-tune them on our specific task. We have several examples of large language models. As I said before, GPT is the most famous one, is one of the most famous one, and is developed by OpenAI. Then there is Lambda and BERT that are developed by Google. And then there is also the Megatron Turing developed by NVIDIA. This kind of models can be used for several common tasks like chatbot or creation of contents or virtual agents that are very used today in the companies. Talking about how to use transformers and large language models with Python, one of the most famous framework, as I said before, is Hugging Face. And Hugging Face is an AI community, open source, very large. It was basically, it started to deal with the natural language process tasks, and now it's going to become, and is already actually very famous also to deal with large language models. And the power thing of Hugging Face is that it can be used also to fine-tune pre-trained models on our own specific data. It has several capabilities, like it has tasks that are used to generate text, or it can be used to make sentiment analysis, and also it can be used to make translation of text. Here, for example, a very basic example on how to use text generation with Hugging Face transformers. Also here you can see that it's very simple because you can import from the pipeline method what you want to do, so basically the text generation, and then choose your model, and then give a prompt as an input and generate a very simple text. Of course, this is a very, very simple example, but basically starting from this very complex application can be built. In the same way, we can do also sentiment analysis, and also here we can use the proper pipeline for sentiment analysis, choose the right model that is already pre-trained and available in Hugging Face, and then also here you can put your text in and make the prediction about the sentiment of the text. And last, text translation. Also here, in a very simple way, with transformers, you can import in your pipeline the model and the method that you want to use and make translation in one of the language that your model is going to support. It seems to be, I mean, it's very simple to see here that in few lines you can build very powerful tools, but today this is the direction that in AI we are going to take, and I will show this later also with LangChain, because basically since today there are a lot of pre-trained algorithms. It's not like a few years ago when you had to build and train your own model and take several days to do it. Now we have a lot of pre-trained things and we can use them out of the box, basically. So the last topic that I want to discuss about is LangChain. LangChain is a very powerful framework designed to simplify the development of applications that are based on large language models. And the powerful thing about LangChain is that it has a very simple interface. It is modular, and it supports a lot of models based on large language, like, for example, GPT, BERT, and so on. The powerful thing about LangChain is that you can orchestrate your application and your code and spend less time to develop, but more time on the application itself and on understand what you are doing, basically. And here, a very brief example on how to use LangChain to build a very common application that is a chatbot. And here, as you have seen for transformers, for Hugging Face, the concept is very similar. With LangChain, you have to import your method and put your input text in, and basically give a response based on very simple instruction. Of course, also here you can use LangChain to make very complex stuff, but you will start from something that is not complicated to deal with. So in conclusion, Python, as usual, has a huge range of libraries that are suitable for generative AI, and it gives the possibility to build, train, and also easily use generative AI models. And it allows to cover a really wide range of use cases in this field. Thanks.
Thank you very much. There are already a few questions in Slido. And one of them, I'm going to read it. It was about I start from the first in chronological order. There was a question, it was just about the definitions. Can you define original the content generated by generative AI? Or do you think that could be like a sort of asterisk that needed there since the model can really memorize? What's your opinion about that?
Well, I mean, is original, but of course there is a bias based on what we give as input, because it's not something that goes alone without any kind of instruction. It's generated based on something that we have to give somehow as input data. So there is a bias on it, basically.
Yeah, thank you. About similar to autoencoders, also SIM, CLR have emerged from constrained learning. Could this architecture be employed as generative models? If you know about it?
Actually, I don't know about it, I have to be honest.
No problem. Do you mind to share more about the current state of the use of transformer architecture in image generation? And do you know any available model with this architecture?
Well, Transformers can be used for image generation and are actually used to do it. But the point is that the way they are evolving with respect to GANs is going in the right direction, but they are not at the same level so far. So they are powerful, but they are still to be studied more.
Thank you. Could you summarize the difference between the long chain that we saw here and other libraries in the same, use the same approach?
The one that I
Yes.
Okay.
I think if the question is in the room, I want to specify it. Otherwise, yeah, let's take it more as a review compared to the others.
Okay. So yeah, just to hear. Long chain is used more. First of all, it's used in particular for large language models and not, for example, for GANs and VAEs. But it is like more something that we can use to build application and orchestrate all the piece of codes, while GANs, TensorFlow PyTorch can be used to build architecture themselves, and Hugging Face is used to use pre-trained built architectures. So this is the main difference.
Thank you. I'd like to ask if there is any more question from the public in here. It was very comprehensive. Perhaps you want to try this library as well. How can we... There was one? Okay, sorry, there was the light in the middle.
What about retraining a model? I mean, the image one, the generative model for image generation, if you want to retrain, or for example, our personal photo. I mean, I heard about Dreamboat as a method to do that. Are there any other possibilities to do this kind of training without spending too much time or resources?
Yeah. So it's basically the same concept of using models that are in the Hugging Face community. You can find here also models that are already built on images and can be used for fine-tuning and basically make the last part of the training on your own data. So this can be done by using less computational power, of course, because you don't have to retrain everything. And basically, you have just to retrain the last layers of the model. And this can be done with any kind of set of data that you have. Of course, here in Hugging Face, but also if you use other pre-trained models, you have to choose the model that is more suitable for your task. If I have, for example, I have to make sentiment analysis, I have to use a model that is pre-trained on this kind of stuff and not a model that is used to give prediction about translation. So there is the possibility, of course. The community is very large, and Hugging Face has a lot of pre-trained model on images.
Thank you. There is a question about, have you ever implemented a stable diffusion model leveraging Python libraries?
No, this is a part that actually I never made, and it's something that I want to start to deal with.
Great, so you can get in contact. Okay. Are there any more questions from the room in here? Okay, okay, where can we find you? Where can we... if someone have follow-up question, what's the best way
LinkedIn.
to... LinkedIn.
Yeah, I think there is on the main page of the talk, I think there is the link.
Okay.
But if not, I try to put it.
Perfect. I think also through your profile and the schedule, you can find the LinkedIn. Okay, Serena Palazzo, thank you very much.
Thanks.
And